Oh, let me just give you a brief introduction. Hello, I'm T. If you're someone who's interested in systems programming, well, then you are at the right place. In this series, we are building our own shell. Yes, we are building a shell just like Bash, Zash, or Fish. And this is day 3, or I can say episode 3 of it. And without further ado, let's begin the show. So, the first thing which we are going to build is string builder. Now, as the name suggests, it's going to build, or I'd say combine strings or characters and create a string. So what are the functions it's going to have? So the first thing is it's going to initialize it. So I need string builder initializer so this is the first function which is going to have. And then we have, just a second. Okay, so the first function will, now we are going to keep the code as clean as we can. So the first function is sub initialize. Then we are going to add a function name sub string builder append character. So append char. Now this function will append a single character into the string builder. Now string builder is going to have a struct. Okay, let me just a second. Why the fuck am I getting this here? Okay, yeah. So string builder is going to have something like this. String builder is going to have a buffer, char pointer buffer. Okay. Then just a second. Then it's going to have a length size t, which is how much characters we are currently storing in the buffer. And then it's going to have the capacity, which is also going to be size t. Now how much is the maximum amount of characters or bytes we can store inside the buffer, including the null terminator. And the initial capacity for our buffer is going to be around 128. Now we will increase it if needed, otherwise it will be 128. So this is the thing. And just a second, like this. So initial capacity is going to be like this, and then the name of it is going to be string builder, something like this. String. Okay, yeah, perfect. So this is the thing which we have, so keep this in mind. So we will append character inside the buffer, each character. And we also have to kind of know if the buffer is full or not. So we'll need one static function for that as well. So, and after that we have append a string. So we will also kind of, if we want, instead of just appending a single character, if we want to append a word, something like this, so we can do that as well. Okay, so that's why we have string builder append string. Just let me just zoom out. And then we have string builder duplicate. Now what this will do is, this will create another buffer. Instead of handling out this our struct buffer, we are going to create another buffer, copy the string builder buffer text into our buffer which we are created, and then return the address of it. Okay, now that's what it's going to do. And then we have another function, that is subclear. Now subclear is not going to free buffer and the string builder, it's just going to make buffer empty and will make the length 0. So we can, again, if we want to start putting another character on the string, we can do that. And then the last thing which we have is sub destroy. Now this is the one which will destroy the buffer and the string builder as well. So these are the functions which we have. So this is kind of how it's looking. Let's go, let's do the coding. So let's go, let's do the coding. Now the first thing is we have to create header file of string builder. Let's do that. Include, let's create header file string builder dot h, and let me just add it, string builder h. Perfect. And define string builder. Now we are going to need some header files, which is standard boolean and standard def, so let's include them as well. Standard def and standard boolean. Let's create the struct which we are going to need. The name is going to be string builder. As I said, it's going to have pointed buffer, and this will store the text which we currently have. The text. Okay. Then yeah, so this will store the text. The next thing which we have is length. Number of characters we currently have. This will be that. Have. And then we'll also have the capacity. Maximum bytes or characters buffer can store. So we've built a struct. Now let me just add the functions declaration. Int sub, okay, sorry, int sub initialize. So it will need the capacity, because on that capacity we will have the buffer. So we will allocate the memory for buffer. So the first thing it will have is string builder itself, and the next thing is it will have capacity. After that we have append char. It will append character. Again we will need string builder, and we will need the character. Let's call it value. Then we also have append string. Again we will need the string builder, and we will also need the text. So something like this. After that we have duplicate, where we will duplicate it. Int sub duplicate. It will have string builder. That's all. Then we have clear. Again it will only have string builder. Then we will have destroy. Let me just add comments here, what each one is going to do. initialize the string builder with default values and allocate memory for buffer. So that's the thing which is going to do. Next, append character. Okay, I just append a single character into the buffer. Then this one, append a string into the buffer, duplicate, copy the buffer into another buffer, copy the buffer text into another buffer, into new buffer, and return it. Yeah, something like this. Sub clear, reset, it will empty the buffer and reset length. Then this one, destroy the buffer and then the string builder. So these are the function and what they do. Let's start building it. src string builder dot c. Let's get started. Now let's include our header file, include string builder h, string builder h, something like this. Let's just check what I have inside here. Okay, sorry, let me just delete this one. Good. Now just a second. Yeah, let's go here. Let's include some header files, which is standard library, and one more thing which is going to be string. And let's just build a function. Let's just start with, what do we have here? Let me just copy this into my Obsidian, so we'll know we don't have to just hover around here and there. So the first function is sub initialize. Let's get started with that. Int sub initialize, so it will have this. The first thing is we have to check whether the string builder has a valid address or not. So if sb is equal to null or capacity is equal to 0, in that case return -1, otherwise we'll move forward. Now what we have inside the buffer, we have inside the string builder, we have buffer, we have length, and we have capacity. So let's allocate memory for the buffer. But before that, I just missed one thing, that is I just have to add define string builder initial size, which is going to be 128, as I said earlier. I just forgot that. Let's just add that, and yeah. Now we have the initial. Now we have the initial size. So let's allocate the memory. Buffer malloc, and then we have to give the size, which is going to be the capacity, right? After that, we have to check if buffer is equal to null, then I have to return -1. Otherwise, we've got the buffer. We've got the address. So the next thing is we haven't stored the buffer like this address into the string builder yet. So we can either do that directly here, or we can just keep it simple and just do it right here. So let's just keep doing that. Sub buffer, which is going to be something like this, and then sub length, which will be 0 because obviously we don't have anything yet, and then sub capacity, which will be equal to capacity, and then that's all, and then return 0. So we build sub initialize. Now the next function which we have to build is append, as you can see here. So the next function which we have to build is this one, which is sub append char int sub append char, this one. Again, for the first thing is we have to check if sb string builder is equal to null or value. Yeah, so it's a value. We don't have to check this one. It can be anything. Return -1. Now here we have to append it, so it's already initialized. We just have to append it. Okay, but before that we have to also check, like, if buffer is equal to null, then also it's a problem. Okay, and after that, after we have checked that buffer is not equal to null, just a second, yeah, then what we have to do is, let's go here, then we can allocate the character, right? Yeah, so now we can do that. Let's go. But before that, we have to check if the capacity is perfect, whether the string builder has the needed capacity. Okay, so before that, let's just, so what we have to do here is, just a second, we have got the string builder. We have to ensure the capacity is there. I mean, the buffer is not full. So let's build a function for that. It's going to be static because it's only going to be used inside this file. So static int ensure capacity is going to have the string builder, and it's going to have the length, the text length, right? Something like this. So text length is going to be size 2. If sb is equal to null or text length is equal to 0, return -1, then we have to get the, now we have to check if the capacity is there, right? So how are we gonna do that? We have length, we have capacity. So we have to combine the, okay, so we will get remaining required length. Can we do that? Required, okay, just a second, size t, required length. The first thing is uh, we will need the remaining size. So how much size is remaining? So how we are gonna get that? Capacity minus the length. So here we got the remaining size. Now what we have to do is we have to check if required size, which is text length. Okay, so let's just not do it text length. Let's rename it to required. And then here, if required is greater than remaining size, in that case we have to increase the buffer size. Then we'll need new capacity, and we will use real log. So we have to pass the buffer, let's be buffer, and then the new size. Okay, sorry, my mistake. We don't have to do this here actually. Here we just have to do this capacity multiply 2. So we have doubled the capacity. After that we will need to just increase the buffer size. So character buffer, and then we will use real log. Okay, what is happening right now? Okay, real log, and then pass buffer. Shit, what the fuck am I doing? Okay, then we will have to use real log. Okay, now we have to pass the buffer, and then we have to give the new capacity here like this. Now we have to check if temp buffer is equal to null. In that case return -1, because we were not being able to we weren't able to just allocate the memory, so we are going to return -1. Otherwise, if we successfully got the address, then the first thing is we have to store that into our own buffer, temp buffer, and then we have to also increase the capacity, new capacity, and then return 0 success status. So we have built ensure capacity as well. So I'm getting here, let's change this to required. Okay, let's go down. Now what we have to do here is we have to check if ensure capacity and then required size, which is length. If it's not equal to 0, return -1. Okay, we'll get the length here. Okay, we already have the length. Actually, it's going to be 2. A null pointer, a null terminator, and the character. So it's going to be 2. And then we have to do one thing, that is in buffer we have to store that. So length will be equal to that value, and then we have to increase the length, and then we have to store the null terminator as well, like this, and then return 0. So sub append, uh, string builder append char is also done. The next one is we have to append string. Let's do that. Int sub append string. So it's going to have something like this. If we have to check first, again in the same way, and one more thing, we have to check text as well, because now it's an address. It's a pointer. Return -1. After that we have to again get, now we have to get the length of text. So text length, which is, we'll use this function and then pass the text. If ensure capacity, and then we have to pass the text length is not equal to 0, return -1. Otherwise we have to just add the text. So how we are going to do that? Something like this: buffer length, and then we have to copy it. Okay, so because yeah, we have to copy it, we can't just store it. So how I'm going to do it is like this: memcpy. Let's use this. Now we have to give the destination, which is buffer. Then we have to give what we have to copy, which is this, and then we have to give how many bytes to copy. So that is the text length. After that, here we have to increase the length plus equal to text length, something like this. After that we have to add the null terminator. Like this, and then return 0. Yeah, so it's working. So we have also added string builder append string. Now we have to create a duplicate function. Now why we stored the, we copied the text instead of just giving it the address, because as you might remember, our buffer has its own address. Okay, like we have allocated memory for it. Now we can't just, it's just storing pointer to char. Okay, now that's why here, and this is const, so we can't just change it or use it, so we have to copy it. That's why we did that. Then we have sub, okay, sorry, something like this. It will have the string builder. Now the first thing is we have to check if it's valid. Then we have to do like, we also have to check if the buffer is valid or not, because buffer is also need to be valid. Buffer is equal to null, or maybe length. Yeah, length also something which matters. Length is equal to 0. In that case also return -1. Now do I have to do that here as well? I guess not. Yeah, and then let's just move forward. Then we have to just create a new buffer where we are going to store, and then it will return it. So let's do that. Destination buffer. Now we are not going to return the this address directly. We are going to allocate the new memory like this, and then we will give that address or pointer. So malloc for length plus 1, because we have to also store the null terminator. That's why if destination buffer is equal to null and return -1, then we have to just copy it. So mem cpy we are going to use, then destination buffer, which is the destin buffer, and then the source, which is buffer, and then how many bytes to copy, which is length, something like this. After that we just, yep, so it's done. Now we have successfully stored the buffer text into the destination buffer, and in that case we just have to return the buffer pointer. Now I'm having some errors here. Okay, yeah, it should be null actually, because we are not returning integer, we are returning in pointer, so it's going to be null like this. Now again I'm having one problem. Sub duplicate conflicting, what, sub duplicate conflicting types for sub duplicate. Okay, this, I might have did something wrong here. As I said, here we have not added the pointer like this. Yeah, perfect. Now let me just update my lazy. Yeah, it's done. Okay, where were we? Okay, complex, let's go. Now we have also built sub duplicate. Why the fuck am I having error? We updated that, right? Okay, the error is saying conflicting types for sub duplicate. What's the problem? Can be declared as pointer to const parameter sb. Okay, let me just check what I've did here. Okay, it's perfectly fine actually. Then why the heck am, okay, yeah, it's returning int. I did a lot of mistakes. Yeah, I do a lot of mistakes. And sometimes you do small mistakes and wonder, like you don't even get it quickly. Like, yeah, sometimes it takes small. It sometimes it takes a lot of time to even correct the small correct a single small mistake. So yeah, it happens. Then we have to build a function subclear which is very simple actually. SB if SB is equal to null, return. And then we also have to do, then we have to like just do this buffer, and we have to make the first character, like the first thing, to null terminator. And yeah, that will do. So it will work, and then we just have to do something like length is equal to 0, and the capacity will stay the same. And then return, we don't have to return anything. Yeah, it's done. Sub clear. Okay, again, right. It doesn't return anything actually. Perfect. Now here, okay, why I've just did like the first address, the first pointer to the null terminator. Let me just show you. Okay, let's do that here. Now we have an address like this. Yeah, we have something like this. Okay, so we have something like this. Now before we had, let's say, some random things over here like characters. Okay, and okay, random characters over here, and then we had null terminator here. What we did is, like, when we print, it checks whether where the null terminator is, and then it prints that much part. Okay, now what we did in subclear is put we took the what we did is we put null terminator in the first thing. So when we'll try to print it, it will get the null terminator, and it will think this it's empty, and then nothing will be print, or we'll get nothing. So that's why we just made the first pointer to null terminator, something like this, and that's how it got worked. Yeah, so let's go. The next function which we have is again destroy, but it's also going to be void, and here I made it int return type it's. So yeah, let's just change that. Void destroy string builder. If string builder is null, then return, otherwise free the string builder buffer first, and then free the string builder, like this. So yeah, it's done. That's it, nothing else. So string builder is done. Yeah, it can be declared, yeah, it can be taken as a const, but we don't want to do that. So let's just keep it like that. So we have successfully did string builder.c. So that's it, done. Now we have to build lexer.c. So a lot of people might not know what lexer.c does. It's going to, like, it. We have a command, something like this: echo hello world. So, like, the shell doesn't understand it directly as a sentence or as a full command. It has to divide this command into multiple tokens. So this will be, let's say, a token word, or this will be a token. Yeah, this will also be a token word. Token word, and like that. Just a second. And like that, our shell has these are we have a lot of operators as well in the shell. Now in the real shell there are a lot of operators, but the operators which we are going to have in our shell are very limited, and let me just explain them to you. The first operator is pipe operator. Now what this pipe operator does is it gives the output from the first command, let's say ls, to grep, so it transfers data. Okay. Yeah, and the next operator which we have is logical or operator. Yeah, and what logical or operator does, so let's say mkdir test a command fails, so the next command, which is this, will only run when the first command will fail. So that's what logical operator does. And we also have and background operator. It just keeps it will run this command in the background, and it will give you to enter the prompt again. Now try running this command and this one command and see what's the difference, so you'll know yourself like what I'm telling you. Then we have logical and operator. Now what does this now what will this do is it will run both the commands. Okay, first it will run mkdir test. If it's successful, then only it will run the second command. That's what it does. Then we have command separator or control operator. It runs multiple commands together. Now these are separate commands. It will run the first command, then it will run the next command. It doesn't matter whether they are failing or not, but yeah, it will run them anyway. So the next we have is output redirection, which will like echo hello, and it will send that hello output into the, like normally when we do echo hello, it prints it to the terminal, but instead of that it will print to the file we have mentioned in this case, which is file.txt. Then we have append output redirection. Now it's the same as output redirection, but instead of replacing the whole content inside that file, it will append it to the end. So I've added some commands after the operator's name, so you can run them and test it yourself. The next thing which we have is input redirection, which will get, like normally when we do cat, we are giving input from our keyboard. So here we are saying instead of taking input from the keyboard, you have to take the input from this file which I've mentioned, which in this case is file.txt, right? The next we have is here doc. Now here doc takes a specific string or text. In this case, if it's eof, now after entering, like you will write this command, you'll hit enter. After that, whatever you'll write, it will save it, and once you've given this string which you've given first, it will end it and it will print whatever you just typed in between that. So in this case it's hello world. You can test it, run this command, and then just type hello world and then eof, then it will print hello world again. So yeah, that's what it does. Now our lexer is basically creating tokens which our parser will use. Now if you don't know, parser is the brain. It will understand those tokens and what they do. So in order to let the parser understand it, we need to create the lexer first. Now we are going to test this command. So it tests everything which our project is going to have. As you can see, this must be the output of it. We have word token, so text hello, text echo, then length of it, which is 4, then what's the line number, what's the column number. Now I know the column number is wrong, but I'm working on that functionality. I'll be working on that. So that's how it is. Now let me just tell you what are the functions which we have. The first function which we have is lexer initialize. This will initialize the lexer struct with the default values. Then we have lexer tokenize. It will tokenize the current character according to like what it is. If it's an operator, it will give it an operator token and it will append it. It will create a token actually. So yeah, I'll show it to you when I'll explain it to you when I'll start coding. I'm just uh, uh, I'm just giving you the overview of it. Then we have lexer peak. So here you provide an index and it will give you that token of, on that index, on that specific index. After that we have lexer destroy. It will destroy every token and it will again make the lexer struct to its default values, so it will have default values again. Now these are the functions which we have, and there might be some other static functions, so let's just get into it. But before getting into writing the lexer.h header file, we are going to need another file which is shell types header file. Now let's get in. This file is going to have our default things, default structs, default constants and all that. So let's just create it. Define shell types h. Then we are going to need some libraries. The first one is standard boolean. Include standard boolean. Okay, sorry, not this one actually. This one. The next one is standard def, standard int. Include standard def. Then we are going to need standard int, and the next one is system types. So let me just include that as well. Yeah, perfect. Now we're going to define some constants, for example shell max arguments now, and shell max path, shell max pipes, prompt max, all that stuff. Let's do that. Define define shell max arguments, like how many arguments maximum we can give. It's 256. Then we have to define shell max path, which is 496. Then I have to define shell max pipes, which is 64. Shell max shell prompt max. So how many characters or bytes our prompt is going to have? Yeah, prompt is like the text we get here, when we I would have shown you, but yeah, let me just show you. So this is the prompt. This is the prompt. I can't. I don't think I'm going to show you this, but yeah, it's kind of this one. This one is the prompt. And shell prompt max is going to be 128. After that, I'm going to create an enum, type def enum and token type. Um, the first thing is token word. Then we have token pipe. Now it will represent a single token. Like if it's a normal word, let me just show you. In here, where is, there you go here. Now this is a token type. What is the value where to which we are going to give token word type? So it's something like this. Now here in this echo is like a token word, and here also word is token word, but you'll think like we have pipe here, why we are giving it a token word. The reason behind that is this word, like this thing, was in double quotes or single quote, so that's why we just stored it as a single word. And as you will see here, we also have pipe, and this wasn't in tokens, sorry, this wasn't inside double quote or single quote, so that's why we've given it pipe. And then we have append, so this is append, token append. Then we have token end as well, double end. Then we have token or as well. Then we have token semicolon as well. Then we have redirect in, redirect out, and we have background as well. And then we have one more token, that is end. So this token represents the end of the command. So when the every argument of the command has been finished, then we set a token end. Let me just check, have I explained you everything? Yeah, I did. The next token which we have is token end. Token end. Then we have token or. Then we have token semicolon. Then we have token background. Token redirect in and redirect out as well. We also have token append, token here doc, token L parenthesis left parenthesis, and token R parenthesis right parenthesis, and token end. So these are the tokens which we have. Now I haven't figured out like how should I go about using the left parenthesis and the right parenthesis, because if I am implementing the code of left and right parenthesis, I think I should also implement the code of like the curly braces and all that, but and the other operators. So I'm not sure if I'm going to put that or not, but yeah, we'll see how we're gonna go about that. Next we have type def, just a second, enum and node type, which is something which you're going to do in the later episodes, but for now let's just create them. Node command. Now this one represents a node, which I'll explain to you later, I guess, and I'll explain it to you later. I'm just going to create these node pipeline, node sequence. Then we have node end, node end, then we have node or, then we have node background, then we have node subshell, then we have to then I have to also create one more thing, that is one more enum actually is going to be redirect type is going to have redirect input, then redirect output, redirect append, and redirect here doc. Now these are the values, like the ones which I told you. Just a second, let me just show you. Yeah, yeah, these are these things. So input, then we have output, then we have append, which is something like this. uh, just a second, I get confused a lot in between them, so yeah, it kind of sucks. Yeah, I was right. This is append. No, actually that was here doc. Append is, yeah. Okay, this one, okay, append is like this one. This one's the append, and then this one's is the here doc. Yeah, perfect. This was here doc. Yeah, I got that. After that, we have one more thing, one more enum, which is job state is going to have job. Now, what's the current state of the job? Now, a job is something. A job is like the execution of the command, whether the execution is happening, whether it's already done or whether it's stopped, and things like that. So we are going to have job running. Then we are going to have job uh, stopped, and the last one is job done. Now these are the jobs which we have. Then I'm going to need a struct, a token struct token, and it's going to have token type. It's going to have these values. It's going to have token type. Now this is the token type. It's going to have text. It's going to have the length of it. It's going to have line count, and it's going to have the column count, the column number. I mean, so let's add them. Add text. Then we have the length of it. Then we have the length, and we have line, and we also have column. Yeah, these are the things which we have inside token. Now I'm not adding comments right now because it's going to make the video a lot of it's going to make this video huge. So yeah, I don't wanna waste time in that. one more struct. We have to add one more struct, that is redirect. Is going to have redirect type, is going to have fd. Now if you don't know what fd is, I'll explain it to you later. Then target, and one more thing, it will point to the next redirect as well. Then we have one more struct, which is command. It's going to have arguments. It will be a something like this, and we have arguments count. We have, it will point to redirect array or the redirect list, which we, it's like a, yeah, we can call it list. So yeah, linked list, it's a linked list, redirects, something like this. And it's also going to have one more thing, which is a boolean, and it's going to be background. Yeah, perfect. And the two more structs which we have. Now I'm not going to declare its properties yet, because we are going to need it in another file, but we are using it here. So I'm just going to declare, just you're going to declare it like, I'm just going to tell my compiler that this struct is going to be there. It's just going to be there later. Now I'm just declaring it. So keep in mind that this is going to exist. So yeah, just like that. Then the last struct which I told you is job. Is going to have pgid. Don't worry, I'm going to explain it to you. Explain to you everything which I'm just doing right now. But just at the time it is needed to be understood. Okay, just a sec. We have char, which is command line, pointed to command line, and then we have struct, which will point to the next job, pointed to next job. Okay, just a second, at the ast node. Perfect. And then we have your type def int is going to be, is going to have pointer to a function. Okay, built-in function, and the function is going to take the arguments like argument count and the argument double pointer, like this. So yeah, we don't have any sort of error. So yeah, we've got this. Now the next file which I have to write is like lexer.h. Now we want to start writing code. So before doing that, we have to just be prepared with header file of it. So we have to add some declarations of our functions. So we're gonna do that first, and we also have to add a struct which is lexer. So let's do that. I'm just gonna go here. I think we've already created this file. Yeah, I already created this file. Um, let's start with defining it. Okay, let's go. So it's Lexo H, perfect. And here I have to define then again. We need some. We need a header file which is shell types because we are going to need token type and all that stuff from that. So let's just include it as well. Shell types, and after that we are going to need two libraries. Let me just check if I have imported them in. You know what, let's just create another header file and let's name it um, common.h, and here we'll include every header file which we are going to need. So the first, let me just add again, if not define common. Why I'm writing command, I don't know. Okay, then let's define it common edge underscore edge, and then what we got to do is let's include standard boolean. We will need uh, I guess we are going to need standard def as well, standard library, of course, standard library. One more thing, let's just import standard int as well. Yeah, perfect. Now let's just keep it that, and let's move here. Now I have imported all the things in common.h, so let's just have it here, not like this. Okay. Now before building this project, you should be aware of the small things about C. Now you don't need experience of like 2 3 years, but yeah, you should be uh, well aware of it. Like from, I guess, I think you should be using it for like 2 to 3 months, and then you'll get used to it. Just give your, I know a lot of people might not have 10 to 15 hours like me, but yeah, someone like me is damn willing to give 10 to 15 hours a day. Like, yeah, I do work 10 to 15 hours a day because I love to. And yeah, that's true that all the days are not going to be equal. Someday you might not work for 15 hours, or maybe not even work. So yeah, it's okay. I don't know why I just started fucking giving speech. Yeah, we are done with the include. Now we have to define the struct. Let's get that. Type def. I'm not fucking Elon Musk or something, so yeah. Type def struct, and then Lexer. At least not yet. Input. But do I wanna be one day? Hell no. Size t, or maybe I do. Okay, size t, position, and then we are going to have, what are we going to have in Lexer? We got the input. Input is like the command we have given, or the command we've wrote. It could be like something like this. Hello, fuck you. No, that is not something I should write. Hello world. Okay, this sounds good. Then the position, like what is the current position we are on, like which character of the input we are on. It could be from 0 to the length of the command or the input for that matter. So it could be 0. The default is like the initial value is going to be 0. Okay, And let's go back. I don't know why I'm having that. I just have to work on it. Like, I don't like it. Then I guess we are going to need to have like which line we are on. Here, like a shell, when you give command, you can give multiple commands on multiple lines. So we need to understand like which line we got. Like if we got an error, like what's the specific line on which we got that error. So we might need to give that. Which line? Which line we are on? Yeah, does that make sense? Because it should actually. Let's move forward. Then we will also going to have column. Now what is column? Let's say, let me just show you with my mouse, even though I'm using NeoVim. So this is column one, this is column 1, this is column 2, and as we'll move forward, like column is going to be as equal as the position, but when the line change, let's say we have echo hello world again on the next line, and when I move to the next line, the line will become 2 and the column will become 1 again. It will go to its initial value. So that's how it's going to be. So what column we are on can be equal to the position. Can be, okay, it's not like it's going to be, but yeah, it can be. Then of course we are going to have tokens, because Lexer is a thing which stores the token. So yeah, it's going to have its own memory. And then we have to know like how much tokens we have saved yet. So the count, the tokens, how many tokens we have currently saved, I guess. Yeah, it's fine, I guess. I don't know what the fuck is happening like this. Okay, and the next thing is capacity, like how much tokens it can store at maximum, right? We have to store that, otherwise we'll never know like how much token we can store, and if we have reached the limit, then we wouldn't be able to, it will just increase the size of tokens, right? So we got to store how much capacity we have got, the total capacity of the tokens, or maybe how many tokens we can store. Okay, and then we have to declare the functions. So let's do that. And Lexer initialize perfect is going to have Lexer, and is going to have pointer to input. Yeah, and what this one is going to do is it will initialize the Lexer with initial, or I can say default values. I hope that sounds perfect. I hope that sounds good. And it's going to return, I guess, returns 0 on success and -1 on error. After that we have got, I think, yeah, after that we'll need Lexer tokenize. So let's do that. Tokenize. Now this one is going to have Lexer. Now what this will do is it will tokenize command we have entered. I hope that makes sense because it should. And then we going to have lexer peak const char lexer peak const lexer, and then we're also going to have the index because we want to know which token we want to return. Again, this one has the same thing like that, so let's paste it. And then um, gives the specified token, right, and returns token on success and null on error. After that we have lexer destroy, which is going to return nothing. Destroy, and it's going to have lexer. it will it will destroy, it will free. Okay, it will free every token, and what it's going to do is, let me just think for a while. I guess it should destroy, yeah, it not I guess it should destroy the token, not token, I mean the lexer itself, and destroy the lexer as well. Okay, it's going to return nothing. After that we are going to have const char token type name. After we are going to have token type name, it's going to receive token type something like this. Yeah, and it's going to return, no, actually I don't think it's necessary, I mean, but you know what, let's just ignore it for a while. Just let's just ignore it, okay, but it's going to be there. I don't think there is any use of that, but we'll keep that in mind. So now that we have successfully got the Lexer Dutch on, let's move to building it. And lexer.c, let's go. I just have to I just have to the include lexer.h, and I'm going to need the string builder as well, because that's what we are going to use, string builder h. And why I'm getting the header cast file not found. Okay, just a second. I think I've did something, I've imported something I should not. Yeah, this one. It will be gone. So we are going to need C type. C type. We are going to need standard boolean, which we have already added that in common.h. We are going to need string, uh, include string.h, include one more thing, that is unit standard, and yeah, I guess that's all what we need. Now the first thing is we need to understand when the current character is an operator and when the current character is a quote, because let me tell you the possibilities that we have. But there are three possibilities: one, it's an operator; one, it's a quote; and the other is that it could be a word, right? So these are the things which we have. So let me just go to my obsidian wall and let me show it there. Okay, this is the one, this is the command. Okay, now ignore these, this one. Let me just take it from here and just paste it here. Okay, I'm just going to get rid of half of it. So just a second, let me see. I don't need this single, I don't need this code, and not this one as well. So let me quickly get rid of everything. Yeah, this much is enough, I guess. So as you can see, this one is word. It starts with a word, so we have to know when it's a word. Okay, so we have to check if first character is word. Then we've got, now we are going to ignore this. This is like escape operator, I guess. Escape operator or escape, yeah, escape operator. Now what it does is it tells compiler the next, don't take the next thing as a, think of a next character. Sorry, what I'm saying now, escape character, yeah. So it tells compiler, think of a next thing as a character rather than an starting character, in this case, right? So because like we are going to have like something like this, we are going to have something like this. So what C will think is like this is the end of the string, but we don't want that. So we want the compiler to think of this one like a character without, yeah, we are just going to think, we are just going to let the compiler think like this is a character and think of it like a character. Don't end my string here. So again we are going to use that here as well, because this is not the end of the string. The end of the string is going to be here, so something like this. But we are not going to enter the command in the terminal like this, so I'm just going to remove it here. Yeah, like this. So here we got it. Now this one is word. Now this one is going to be a word again because it's in code, so we have to know when it is a code and start picking every word inside it, and until the code ends. Then again it's a word, and then it's operator. So again we have to know when the current character is operator, and then we have this, which is again word. So we have three things. Let me just show you. The one thing is word. Okay, the next one is going to be quote. No, not like this actually. Word, and we have quote, and we have, okay. So what are the things we have? We have a character, normal character. We can have a quote. It could be a single or double quote, doesn't matter. And then we are going to have an operator. So we have three possibilities basically. So we are going to just keep that in mind. Yeah, perfect. So let's go here. Now the first thing is how we're going to get the first. Let's start with operator, understanding like knowing what an operator is, if the current character is operator or not. So let's create a static function is operator char, and it's going to receive a single character like this. Now let's use a switch statement. Let's pass C here. If the case is AND operator, like it's not AND, I mean background, so return true. If it's a pipe, like this, again return true. If it's output redirection, again return true. Case input redirection, again return true. Then we have semicolon. Yeah, I forgot to add that. We have semicolon as well. Just keep that in mind. I'm not going to add that now in my Obsidian. True. And default is like going to be nothing. Default is going to return -1. False. I mean, yeah, that's it. Now, why the hell my Alexa.touch is giving me error? Maybe because I am standard boolean standard int. What's the fucking problem? Yeah, here also I'm importing it. I don't think these two are necessary. This one is also not necessary. Yeah, these are the ones which we need. Include file. Okay, again I have some error. Job. Okay, job state, and we have not added job state, have we? Yeah, we have added. Yeah, I've added job state. Why the fuck am I getting error? Yeah, there's this wrong. Job state. Yeah, now it's working. Found a statement that begins with bool constant. Okay, rebound code. Yeah, I know a lot of people must be thinking, why don't I go live and do it like that? But for the people who live in India, who might know that all the things which happen in India is all of a sudden and immediate. So, like, and I'm a wretch when it comes to recording videos. I mean, I'm unfortunate because whenever I sit down to record videos, something outside my house or outside my building, someone starts working and starts creating a hell of a lot noise. So yeah, and then I have to stop recording because I obviously can't record in that much noise. So I'm truly unfortunate when it comes to that. So yeah, but I have to work. Then I have to adjust my schedule according to that. So that's why we can't have live at least now. When and I'm okay with that actually. I have to be okay with it. I don't have any other options. So yeah, yeah. I'm from India for the people who don't know, and you'll start knowing about me later. Let's get into coding because I know you're not here to know about me if you're watching this kind of huge project because it's obviously a hectic project. So now that we have got the function working, I mean it's going to work. It's a very normal function. I'm just going to declare function that is going to be append token. Now we are going to need a function which will append the token. So we are going to keep it everything in separate in their own files. So for append token, we have different file as well. It's going to receive lexer, then it's going to receive token type, then the text itself, the pointer to text, I mean, and the length of it. So we can copy that much, and it's going to be sized. So we can copy that, yeah. Now we are going to need lex word. As I said earlier, like we need to know if the current character is a word or not. So for that we are going to need lex word. Now, but there's one problem here, because we might have something like this, okay, where this whole command is just one word. Yeah, this one is one word because we have added like the escape character, and to which essentially means that ignore the space and add these two separate words as just a single word. So we have to do solve that as well. And one more thing, um, we have this semicolon thing here as well, which comes under operator. So yeah, let's go. Now let's just add static int lex word. It's going to receive the lexer. Now here we are going to use the string builder. The first thing which we have to do is we have to check if the lexer is not null. If it's null, then it's a problem. Then we have to check if the input is null. After that, if it's null, then return -1. After that, what we have to do is let's create a string builder. String builder, let's call it SB, and let's give malloc size of pointer to SB. We can do this, or you can just give, which means the same thing for now, but if you later changed this one to, let's say, lexer, then you have to change it over here as well. So I'd rather use this. Then we have to check if SB is equal to null, then return -1. After that we have to initialize it, initialize SB initialize. Then we have to give the string builder and the capacity which we have initial. Let's check initial string builder size, string builder initial size. If it's not equal to 0, then return -1. after that what we are going to need, we are going to need the current character and address of it, because we have to calculate the length, and then we have to check whether the what's the current character is. So let's do that. So size t start position, which will be like this, lexer position, and then we will also need the start position address, lexer input plus lexer position. After that, we have to solve that escape character problem like this thing. So for that, I'm just going to create a boolean is space, which is going to be false for now. And one more thing is escape character, and it's going to be false as well. Then we'll start the while loop, and we have to check if the current character um, input lexer position, if it's not equal to null terminator, then we have to move forward, and then we have to check if it's not an operator, because it should be an operator. Then if it's not is operator, operator char, yeah, then also we have to move forward, and it should it shouldn't be a space. Yeah, it shouldn't be a space. So we are going to use a space. If it's not space, then only which takes the current character, lexer input lexer position, and I just have to add an or operator, another expression that is going to be is space, or is space should be true. Now I'm going to explain to you what this means, and we'll go through it one by one. Let's go. Now let's see, let's just say this is a command echo. Now e is not equal to null terminator, so this one is true. Again, it's not an operator, this one is true as well. And it's not space, so this one is true now. If it's not space, so this one is true, so we will get inside it. And then when we will have an escape character, what will happen is our space will be true, and then yeah, then we will be here on this space, and let's say this one is false, this one is true, again it is not equal to, and this one is also true. Now this one will be false, but this one will be true, so we will again enter the while loop, and it will not be breaked, and yeah, then it will work again. So that's kind of how it's going to be. So we have to check first if lexer input lexer position, if it's not equal to escape character, because we don't have to add the escape character inside the word, right? So we don't have to add it, so that's what we're going to do. If sub append cat, then we have to give the string builder, and then we have to give the value, which is lexer input lexer position, like this. If it's not equal to 0, return -1, and then we have to free the sub as well. Yeah, free the string builder as well. After that, once we have checked that, we have to check if let's say the lexer input lexer position, if it's equal to escape character, then escape character and is space, and if it's not space, I mean if its space is false, then what we'll do is space will become true, and also is escape character will become true, like this. Else, I mean if no we I just have to use it, my mistake. I have to use else if lexer, if like, then what we have to do is we have to check like if it's a space now, right? So if it's space, and if a space is true, then we have to make space false, because then uh, we have used the one space, right? So let's do that. So how we're gonna do that? If a space is true, and if it's a space, lexer input lexer position, then we have to make a space false. Now you must be wondering why I'm not making is escape character false, because we are going to need that later while adding the length of the token and all that, as you can yeah. So that's why I'm not just okay. I'm getting an error saying called object type boolean is not a function or a pointer. Okay, what the hell did I do wrong? Just a sec. Let's go here. Okay, I've imported C type, and C type does have is space, right? Yeah, yeah, it doesn't have any underscore. Sorry, fuck. It's something like this. It doesn't have any underscore, so keep that in mind. And we have to one more thing. We have to check like if the current character is this, and I think I need to check if lexer input lexer word lexer and position, if the next, okay, lexer position plus 1, I mean the next character, if it's not equal to a space, not this one, motherfucker. Lexer input lexer position, then then we have to return, we have to free the string builder, and we also need to, just a sec, we also need to, yeah, we have freed the string builder, we need to return -1, because yeah, when you are using escape character, Then the next thing which we have should be a space. If it's not a space, then it's a problem. Like the next immediate thing should be a space. If you have space here, then we just can't add that, right? Because that's something which is wrong. So obviously we can't add that. So yeah, let's go. What you have to do is now let's go. We need to increase the position, right? Lexer position plus plus, because that's how we will move forward. And we also have to increase the column. As I said, we have column as well, so we have to do that as well. After that, we have to check if is like if is escape character is true, then we have got a escape character inside our command. So in that case, the length is going to be different, and the text is also going to be different. So for that reason, if we are going to do that differently, append token, give the lexer, don't then give the token word, because it's going to be token word. Then instead of giving the text like this, we are going to give sub. Okay, we are going to need one thing. Let's just do it like this: text. I haven't defined text yet, so don't worry about it. And length as well, because I haven't defined that as well. So let's get the text. Char text sub duplicate and give the string builder. Then check if text is equal to null, free string builder and return -1. Now after that, here it should be string builder and then length of it. Perfect. Then if it's equal to 0, that means we've got an error. If it's not equal to 0, that means we've got an error. Again, free string builder and return -1. Else, then no, not here, actually I don't have to use else here. Then otherwise return 0. And else, like if we don't have escape character inside of a command, in that case we just have to append the token normally as we do. So we have to get the length, size t, length, which is going to be lexer position minus current start position actually. And then if append token lexer token word start address, and then the length which we have got, if it's not equal to 0, return -1, else return 0, and here we have to return -1. So this function is done. Text variable can be declared as pointed to const. Yeah, I can do that, and I just did. So yeah, so this one is done. After that, let's start with the other function, which is, now we have got this one covered, this one word and character, I mean, and also operator. Now we are not adding operator, we just we are just recognizing it. So let's move to this one, quote. Let's add a quote word inside the quotes. So let's do that. So static int is quote char, and it's going to get const char c. Now if c is equal to single quote, or c is equal to double quote, then return 0, else return -1. So it's just a simple function which recognizes whether the current character is a quote or not, nothing else. Now we'll add the quote word. Static int, what should be the name of the function? We added lex word, so let's make it quote word. Is going to receive lexer if lexer is equal to null, or lexer input is equal to null, return -1. Yeah, so this is what we have to return. It's done. Yeah, so let's let me just do it like this. So I'm just going to add a boolean, like we need to know if we are inside quote or not. So inside quote, now initially is going to be false obviously, then we are going to get the current character, start char, lexer input, lexer position. If the start char is equal to, okay, we have the function. So if is quote char and start char, okay, I don't need this, actually it's a character directly. So is not equal to 0, in that case return -1, because it's not a quote char. Otherwise we will const char, we will store the start address, lexer input plus lexer position plus 1, like y plus 1. Let me just tell you that, just a second. Now y plus 1, so let's go here. Now here, as you can see, where is that? Yeah, here. Now we don't want to add this quote inside our word token, we just need to add this text, and we have to ignore this and this. So that's why I'm not taking the address of this one, rather I'm taking the address of this edge. So that's what we are doing. and also we have to store the position of this edge. So yeah, essentially I'm storing the position of edge and the address of it, because we are going to need both. After that, size t start position lexer position plus 1. Then we will use while inside quote is equal to false, or lexer lexer input lexer position. If it's not equal to like the null terminator, then just keep moving forward. So here is initially we have false, so this will be true and this will be true as well. So once we are in, we have to check if it's uh, lexer input lexer position. I know we have to use it a lot. If it's a quote, then if it's a quote and then inside quote is equal to false, then means this is the first quote which we have got. So what I have to do is I have to do inside quote to true, and also have to increase the position. So lexer position plus plus, that's it. Just a sec. Yeah, after that we have to again check if is quote is there. Is quote um, lexer input lexer position. If it's a quote, and if inside quote is equal to true, that means it's the end quote. Then what we have to do is make inside quote as false and then break the while loop. Otherwise we just have to keep increasing the position. Now here also we can just continue. This will also work, and without continue will also work. So what's going to happen here is, let me just show you. We have, let's say we have this command, not this. Which one? Yeah, let's say we have this command. So we are here. Let's just thought about this one. This part. We are here inside a code. We are inside code. Just a sec. Yeah, we are inside code, and the first thing is, let me just copy it. So I just don't have to move around too much. Let's go here. Okay, so the first thing we have, let's say, is we have this code on our current position. So we will start from here. This is false. In start char we have the code. Now this will be true. So we will have the start address of h and start position of h. Now we'll enter the while loop, because inside code is false, as well as, sorry, yeah, inside code false is true, and we also don't have the null character in current cat, so this will be true. We have inside loop, we are inside loop now. So is current code, now we still have lexer position pointing to this code, right? So inside is code char lexer input lexer position, this one is true, and inside code is also false, so this one is true. We have increased the position, we have made inside code true, and we are continuing. So now we went from this code to h, and now inside code is also false. So now we will again enter, we will be here with h. So here we'll check again, is this a code? No, it's not a code, and this is also not true, so this will skip this one. Now we are here again, this will also be skipped. Increase alexa position, now we'll skip. Now we will, let's say we will add this, we have add this until o, and then we are here to the space. Now we have space again, both this one is true because it's not null at terminator. This one will be skipped, this one will be skipped. Again we have increased the position, so we got this one as well. Then we will add all these, so you can just see, check that by yourself. I'm not gonna check that. Now we are at the last token, let's say we are at the t, so we got the t. Now again we skip these two, we increase the position. Now we are at this code, so we are here, it will skip it because inside code is true, but here we are checking if it's false, so it will skip this one. Now we are here, is code char. Let me, yeah, it's code char. So yeah, it's a code char, and inside code is true. Yeah, inside code is true as well. So we will make inside code to false, and we will break the loop. But the thing which I'm wondering about is, like, should I make like increase lexer position? I think I should, because we have to move the lexer position, right? So yeah, I'm just going to do that. Just let's move forward for now. I'll add that later. If inside code is true, that means the user just have typed just a single code and the end code is missing. In that case, you return -1. Then we have to get the length, size t, length, lexer position minus start position. Now lexer position is pointing to this. Yeah, I think I need to increase it to the end. Lexer position, so this minus lexer position is pointing here. Like, actually I was pointing with my hand, but yeah, let's point with cursor because then you would know. So we are currently here, and this minus the length of it, so yeah, it's going to work. Start position. After that we have to append token lexer token word. Text is going to be the start address, and length is going to be length. If it's not equal to 0, is return -1. After that I have to increase the position just to move forward, and then return 0 because we have succeed. adding the token word. The next thing we're gonna do is the next thing we have to do is add lexer operator. So let's do that. Static int lex operator. Should I name it this or like operator word? No, no, lex operator sounds good. Is going to receive lexer like this. If lexer is equal to null or lexer input is equal to null, ret- return -1. After that we need to get the operator, start operator. So character start operator lexer input lexer position. So we are going to need the address of it as well. Start operator address lexer input lexer position, and we are also going to need the next operator address or the next operator. So let's add that here. Char next operator lexer input lexer position. Now in here, we don't need a while loop because we are just going to have either one operator or two, and there's not going to be more than two operators, so we just have to check for that. And if it does, then we just have to add them like as a token word. So yeah, let's do that. So then we need to store like the token type and length of it, so it can either be one or two, and it can be different token names. So let's do that. Token type and size t. Why the fuck am I getting that? Token type and then size t, length. Let's start the switch case. So I have to check if operator, if start operator is if it's equal to the null terminator, or if it's a space, if it's a space, or if it's not is operator char. In that case return -1 because it should be in those values. In that it should be an operator character. Then I have to use switch statement. I don't know why I say switch case. And then start operator. If the case is this background operator, and if the next operator is equal to the end as well, in that case the type is going to be token end, and the length is going to be 2, else the type is going to be background token background, this one, and the length is going to be 1, and then I just have to break it. Case output input redirection output redirection, sorry. If next operator is also equal to the output redirect, this greater than sign, then what should I ask, what should it be? Type is going to be here doc, token here doc, and length is going to be 2, else type is going to be token redirect 10, and length is going to be 1, and let's break it. After that case, this, sorry, that was a less than sign, it's this one is greater than sign, my mistake. Here we have to check if next operator is also the same type of character, then the type is going to be token append, and the length is going to be 2, else are you kidding me? Otherwise it's going to be, it started raining outside my house, but it shouldn't be much of a problem. You know what? Fuck it. Other else the token type is going to be redirect output, broken redirect out, and the length is going to be, what should it be? Length should be 1, and we are gonna break it. That's the thing which I'm talking about previously. Now suddenly it has started raining outside my house, and I can hear all the voice and all that, so it's quite exhausting. So that's why I'm just gonna continue later when the raining has stopped and there's no noise outside. Yep, so after this what we have to add is case, we have to add this pipe like this, and we have to check if the next token is also this, then the next character actually, so the next operator is also equal to this. In that case what we have to do is we have to give the type as or, token or, and the length of it will be 2, else it's going to be type token pipe, and the length will be absolutely 1, and then we'll break it. The next after this, why the fuck, yeah, perfect. The next after this is case, it's going to be semicolon, yeah, it's going to be semicolon, and it's just one, there's not it's not going to have two semicolons back to back, so yeah, we don't have to use if and else. So here the type is going to be token token semicolon, and length will be 1, and then break, and the default will return -1, like this. So yeah, so the reason I'm getting the problem is like, now it will work, yeah, just a sec. Yeah, perfect. Let me just make it like this here. Now what we have to do is we have to append the token. lex operator. Now we have to append the token. So for that we have a function which is append token. If append token lexer type, and here we have to give the text address. So that's how, let's convert it to concat pointer, and then we have stored the address actually. So yeah, this one, and then we have got to give the length which we also have. So if it's not equal to 0, if length if length is not, I mean if it's not equal to 0, return value, then we will return -1. Otherwise, increase the lexer position, increase the lexer position by length, and then return 0 because we have succeeded then. Again, I forgot to bring my water bottle, but yeah, that's okay. Now the next function we gotta build is append token. Static int append token is going to have lexer, then it's going to have token type and an address, const char text and size t length, like this. So first we have to check if lexer is equal to null, or lexer input is equal to null, or actually, let's just do something like this. Just a sec. Let's delete this much, and then return -1 if lexer is null, return 1. Now we have to check if type is not equal to end token. Now our end token is not going to have any text in text. Yeah, in text address, like here, is going to have null, length is going to be 0, and type token is going to be token end. So yeah, so if it's not equal to token end, and and text is equal to null, or length is equal to 0, in that case return -1, because then it's an invalid token. Now why the heck am I so just a sec. Here I have to write type. After that, what we have to check is, like, if lexer count is greater than the lexer capacity, so we have to check whether the capacity of the token, like we have the capacity full. If it's full, then we need to reallocate memory using real lock, and yeah, that's what you have to do basically. So I gotta check. So if it's greater than equal to lexer, not fucking length bro, lexer capacity -1, and if it's greater than, then we have to check if lexer capacity is greater than size max divided by 2. Now what we are doing here is, like, we are going to store the news capacity. Because the capacity is full, we are going to multiply capacity by 2, but it can just reach out of the limit of the size max. Size max is the maximum amount of bytes int can store. So size t can store actually. So it can, if it yeah, it can go out of its reach. So that could be a problem. So what we have to do here is we have to check if, instead of multiplying capacity and then checking, we are dividing size t by 2, and then we are checking if capacity is greater than uh, size max. If it is, then yeah, it's going to just overflow. Otherwise it can size the size t can store the new capacity. After checking this, we have to store the new capacity, which will, as I said, will be Lexer capacity multiply 2. Then we have to check if new capacity. Now we are going to allocate uh, new tokens for with the new capacity. So again, we have to check if size max is going to overflow or not. So yeah, is equal to size max divided by size of, we can do token, or yeah, let's do token. Other instead of doing token, let's do something like this. Lexer tokens, like it eventually points to token struct, so you don't have to worry about that. In that case, return -1. Otherwise, we have to allocate memory token temp real lock Lexer tokens, and then the how much the new capacity, which is size of Lexer tokens, like this. If temp is equal to null, that means we did not didn't got the we have not got the address, the pointer. So in that case, we have to return -1. So after that, what we have to do is, then we have to store that temporary take if you got the address, then we have to store it inside tokens. So it will be a new memory, updated memory. And then in capacity also, we ought to store the new capacity because we have increased it. Why the fuck am I getting it? Oh. So if length is equal to size max, then again it can't be stored, so again return -1. Now it is very unlikely that this will happen, but yeah, we have to be prepared for that as well. Lexer to now we have to allocate memory for the text which we've got. So let's do that. Lexer tokens Lexer count dot text, and let's allocate memory malloc, and how much is going to be length +1. Why +1? Because we want to allocate memory for the null terminator as well, so we got to do that. If Lexer, just a sec. Then let's just store it because we're gonna need it. Token Lexer tokens Lexer count like this, and then let's check if token text is equal to null, then return -1. After that, we have to copy the text into the new memory which we've got, because right now it's just empty. It's just memory with random things on it, random bytes. So we need to store the text which we have got, right? So memcpy, I'm going to use memcpy memory copy, I guess. Then we have to give destination, which is token text. Then we have to give the new text which we have, and then we have to give the, which is length plus 1. So let's just give length. After that, we have to store the null terminator as well. Text length equal to the null terminator, like this. Then we have to store the length, which is going to be equal to length. We have to store the line, which is going to be equal to lexer line. Then we also have to store the column, which is also going to be lexer column. After that, type token type, which is going to be type, and then increase the lexer count. We have to increase the lexer count because we have just added a token, and then return 0, like this. Now here, okay, good. Now the next thing which we have to do is lexer initialize. What we have, let's check first what we have. What do we have inside that? I mean, what input position, line, column, tokens. Yeah, gotcha. Let's do this. Int lexer initialize if lexer is equal to null, or lexer input is equal to null, return -1. Then lexer, let's just first make all the values properties so it's default. So input null, lexer position to 0, lexer line to 1, lexer column to 1, lexer tokens to null, lexer count to 0, and lexer capacity to initial. So I forgot to add the lexer initial capacity, which is going to be here. Define lexer initial capacity, which is going to be 64, like this. And then here I can give lexer initial capacity like this. And then input lexer lexer input will be equal to the input which we've got. Now here count, yeah, So after that, if lexer initial capacity is greater than size max divided by size of size of token, then return -1. Otherwise we will allocate memory for it. Lexer tokens malloc capacity lexer capacity multiplies size of lexer tokens. Now I think I have imported something which I should, which is this. So I'm going to delete it and let's go here. um, After that, if lexer tokens is equal to null, return -1. Otherwise we are to return 0 because then we have succeeded to initialize the lexer. So lexer initialization is done, so let's get out of this. So the next thing we got to build, let me check here. Let's see. We have to build lexer token as lexer peak. So we have built lexer initialize. So let's go. The next is int lexer tokenize. If lexer is equal to null, or lexer input is equal to null, or lexer tokens is equal to null, return -1. Then we just have to just initial get the in value the its properties to its default values. So lexer position will be 0 just for safety, line will be 1, the lexer column will be 1, and lexer count will be 0. After that we will use while loop, because we are going to have we have to go through each character inside the command. Something, the command will be something like this. Let's go with an easy command, something like this. Okay, it will be something like this. The first thing we got to do is we have to check if lexer input lexer position is not equal to null terminator, because if it's to the now if we've got to the end, then there's nothing forward to go with. In that case we have to stop. So that's why if is space lexer input lexer position, if it's a space, then we have to check which kind of space it is. We have to check if lexer position, no, lexer input lexer position, if it's equal to like the new line character, then what we have to do is we have to increase the we have to increase the line count and the column, and make the column to 1. So lexer line, so we will increase the line count like this, and like this, and then we will also have to make the column to 1, because again we've got to the first character on the new line. So else we just have to increase the column lexer column plus plus, and then we have to increase the position because we have to go to the next character as well. And then I'll just not like this, like this. And then we have to continue like this, because we don't need to go forward. Like if it's a space, the just check which space it is. If it's a new line space, then just increase the line count and change the column, and then just increase the column and just move forward position and then continue to the next character. There's nothing forward you can go with. So yeah, then we have to use else if. Now first we have to check for quote, because if we used lex word first, then um, it will take the quote as a word. So yeah, it will add it, but we don't want that, so that's why we use first is quote. So is quote char lexer input lexer position. If it's a quote char, then just run, then add just quote word, pass the lexer. If it's not equal to 0, return -1. Then yeah, then again I have to use else if. Else if is, now we have to add is operator because it can be operator. Lexer input lexer position. If lexer position if it's not equal to, no, actually is operator guy, it will return true. Then we have to do something like if is lex operator, then just pass the lexer. If it's not equal to 0, return -1. Then else, now we have got to the lex word. In the end it's a lex word, so if lex word add and give lexer. If it's not equal to 0, that means we got error, so return -1. And in the end, after the while loop, we have to add the this token end. Let me show you. They're not here actually. So yeah, this token, we have to add this token in the end. Doesn't matter what command it is, we have to add this token. So let's add it. If append token lexer token end, and as I said, its pointer to text is not going to be there, so it's going to be null, and then length is going to be 0, not 9, 0. If not equal to 0, return -1, otherwise return 0. Yep, so what is the next function we got to build? I think it's something lexer peak, not sure. Yeah, lexer peak and lexer destroy. Let's just build them quickly. They are just piece of cake. Let's go. Let's eat that piece of cake. Const token lexer peak, and then it's going to have something like lex, I guess. Lexer, like pointed to pointer to const lexer size t and index, because yeah, we have to have the index. If lexer is equal to null, return null. Otherwise, again we have to check if index, like if it someone could anyone can provide wrong kind of index, so we have to just check through that as well. So if index is greater than lexer count, return null. Then we can just return the address of that token on that index like this. Okay, so I think I just did something wrong declaration. Let's check. Lexo peak const char. Yeah, no, the declaration is right, but here I just did something wrong. That is this one. It should be character. It's a pointer. It's going to return pointer to const char. Nope, nope, nope. Here it was right. Sorry, it's not going to. It's going to return token. Yeah. Let's go token like this. So I guess we are done here. Just a sec. Let me check. No. Yeah. Now we are done here. Let's go. Lexer peak is also done. I think the last function which we have. Let me check. I don't know what's the last function. It should be, yeah, Lexer destroy. What what did I told you? What do we have to free and destroy? I think we need to free the tokens, and then we need to destroy the Lexer itself. Cause yeah, if we are not going to destroy the Lexer, like it's not essential that we have to or we need to destroy the Lexer, because we can just store the next tokens. We can do that. Let me think. What do we have to do? What do we have to do? Let's see. Let's build it first. Lexer destroy is going to have Lexer pointer. If Lexer is equal to null, then return. Then we have to go through each token. For size ti is equal to 0, if I is less than Lexer count, then I plus plus, then just free every token. So Lexer tokens and then I. Okay, we have to free the text first actually, then we can just, yeah, we are going to each token and yeah, gotcha. Then we just can directly free the Lexer tokens like this. Then we can just do something like tokens to null. We are not going to free the Lexer. We are just going to make keep it with its default values. Lexer input null, Lexer line 1, Lexer column 1, Lexer count 0, Lexer capacity, Lexer initial capacity, and return this. Yeah, we are done. Now the last function which I mentioned, we are not going to build that, or should we? Let's this token type name function. Let's just build it. It's just easy. There's nothing to just worry about. It's too easy. Const char token type name. It's going to receive token type switch. You know what? We shouldn't build it. Let's delete it. We don't need that. And we are done. We are done here. Why the heck am I getting error? What's the error? The result is used in bitwise operation. Yeah. Okay. Yeah. I just use single this. So yeah. I think we have one more error here somewhere. Let's check. Cause yeah, this one. Now it's good. So we have built Alexa. So we have built Alexa, but we are not done yet. We have one more job to do, that is to test it. So I'm just going to create a test folder and add test alexa.c. Here I'm going to include alexa.h. Include header is not used directly. Okay, that's because I just fucked up. Delete. We have to create this. It's not a folder, it's a fucking file. Yes, delete it and create a fucking folder, dude. Test and like this. And then we have to create test lexer.c. include include yup, 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 yup. include lexer.h like this, and then int test lexer. Now let me just go here. Let's open lexer.h. Now here first thing is lexer initialize. So let's do that. Lexer malloc size of lexer. After that, size of lexer. If lexer is equal to null, and return -1. After that lexer, then we are going to need the input, which we have here. Let me show you this one. Copy it. I'm just gonna copy it and just paste it here. There you go. After that, we have to initialize lexer. If lexer initialize lexer and then the input, if not equal to 0, return -1. Then we have to tokenize it. if lexer tokenized lexer is not equal to 0, return -1. Now that's it. And then return, no, we have to print it actually. We have got the lexer. So what I can do is we can, for size t, I is equal to 0 if I is less than lexer count I plus plus. Then we can do something like printf. So what should I do? Yeah, here we are going to need that thing, but okay. So the first thing we need to, let me go here. Let's check what we have token. So we can, I need to print token. So we have to print string type, something like this. But the problem is, let me just show you the problem. So token token lexer tokens, and then I. So here token type like this, and just copy this thing. Okay, it's not a pointer actually. And then here I need to change this as well to dot, like this. Printf type, it's going to be a like integer, so I need to do d here. Printf, okay, we need to add include standard input output header file, and then I'm going to just, okay, not like this, copy this, go and paste this, paste this, paste this, paste this, like this. And then I'm just going to change the things. Length, no, text. Let's do text first, then length, then the line, then the column, and then according to that we need to change this as well. This is good, this is also good, this is also good. This is going to be um, a string, so like this. Okay, it's size t, no, it's Z here. Yeah, now we're good. And just so we will understand everything, I'm just going to separate it with this thing, like this. Like this, and yeah, good to go. and then return 0. So yeah, this is it. We have to test it, but trust me, it's going to work. I want to end this video actually because I have another work to do, but I also want to I also want to upload a complete video rather than uploading an incomplete one. So yeah, let's do it. Let's do it. Okay, just create a make file here. Make file, and not here actually, outside, like here, something like make file, and just paste this code inside it. I'll just download cmake, and then create main.c as well, and just include. Okay, there's one more problem actually. I need to create one file here, that is test.h, and then if not define test h, define something like this, and then just int test lexer, and it needs nothing. Do this, and yeah, that's it. Inside main, just include that file. Okay, I'm not inside a folder. I can do something like this, and then test.h, and then create a function main. If test lexer is not equal to 0, return -1, else return 0. Now hopefully it should work. Make run. I've got an error, const, which is lexer.h41 const token type name. Okay, we have not built that, so you know what, let's just delete this and let's run make. Okay, let's clear first. Let's clear it. Make run. Okay, there's one problem again. What's in function lexer.c undefined reference to sub initialize. Okay, maybe we have fucked up somewhere. String builder is there, then what the fuck, we ld returned one exit status. Okay, there's something wrong, let me check. uh, Sub initialize, what is the line number in function lex word? Okay, lex word. The thing which is wrong is, I know what is wrong, I guess this one. Let's change this to string builder actually, like this. Make run. Okay, again undefined reference to sub initialize. Sub initialize, what the heck is wrong? Undefined reference to sub append and sub. Yeah, so the problem is that we have not mentioned string builder file here. Src string builder dot c. Now it should work. Not uv actually. I thought I'm running a Python program. So make run. So error 255. we've got another error here. mm, okay, what is error 255? So it took me a lot of time, but I figured it out, like what's wrong. The thing which is wrong is this one. And so here I did lecture input, because lecture input is not going to be in there because we haven't initialized it yet, so it should be input. And let me delete this, and this one is here. And let's try to run now. Now again I've got an error. Let's run it again. Okay, now the problem is in this function. So there's one more problem which we have to solve first, that is inside lecture append. Just a sec. Where am I appending a just a token end? Yeah, where are token end? Yeah, this one. Now here I'm giving it a null, but in append token I have to check. Okay, line length size max. Then then we need to check the type here. I mean, like, if type is equal to token end, then we can do something like token save type as token end, then token text is going to be null, token line is going to be lecture line, token column is going to be lecture column, and token length is going to be 0. Yep. So, and we also have error in I mean error by error I mean we have bug. Where is my lex operator? Yeah, here. So here we are not giving, we have to do position plus 1 like this. Now the one thing which I did wrong is, like, I have to convert this to like unsigned char. So let's just do that like this. Then let's go to the next one. Now here, instead of doing this, we can do it something simpler, like this. And then again here also we have to convert it to unsigned char. Let's go to the next one, unsigned char, like this. Do we have next? Yeah, unsigned char. Again next, unsigned char. Yeah, good. And I found another bug, which is append token here. Now the bug is here. Now once I've did this, I just have to increase the count and then return 0. In lex word also, lex word, here we are not like, just we have to destroy the string builder. Let's copy it. Why the okay, it's now, yeah. Then here, instead of this, I can sub destroy sp like this. Here also. Then where am I returning something? Here also, here also, and here also. Let's delete these. This one as well. Good. There's one more problem in here. We are not increasing like the position. So and the column the code is also quite wrong. So we are going to fix the bugs later. Right now it's going to work, so we are going to keep it that way. And lex operator, lex tokenize, we have to increase the position here as well. Column, sorry, not position, we are already increasing the position. We have to increase no, actually not here. We have to do that in operator lex. Yeah, we have to do that here. We have to also increase lexer column plus equal to the length. Okay, so now let's check if it's working on. So now I have did some changes in the lex word and no, not lex word actually. Yeah, in lex word as well as in quote word and is quote char functions, and also in tokenize lexer tokenizer. So just check it out because I forgot to just record it. So you have to check it out on GitHub. Just compare it. Let's see if it's working right now. So yeah, it's working, I guess. We've got 24 tokens, echo hello world text. Let's compare it with that one. We've got 23 tokens, 23 tokens. Perfect. So it's working.